Hey, welcome America, India, and Taylor Swift to our live recording in Studio 212 today. I am going to start from the very beginning. I need all phones away and eyes up here. I'm going to start from the very beginning. This is an Algebra 1 course I'm going to be teaching you today. I'm going to teach you how to simplify radicals. We just reviewed our multiplication times tables. The phones need to go away. The phones need to go away. There we go. And now we're going to simplify radicals, and then we're going to multiply radicals, and then we are going to rationalize the denominator. Right now, let's see if I can use this. Okay, so let's start with what perfect square numbers are. Okay, so if I take a square, okay, the length of each side is 2. 2 times 2 is 4, right? And you learned back in 3rd grade, if you make that into a box, there are four boxes. And so that 2 times 2 is 4. 4 is a perfect square because the square root of 4 is 2. Is everybody with me? Okay, so now I'm going to go ahead and list the perfect squares. So 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. This is why we just reviewed our multiplication facts. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. Those are really all the ones we're going to need today. Okay? So if you're given a square root that's a perfect square, and you're asked to, what's the square root of 81? Well, that's just going to be 9. Okay? However, sometimes you're asked to simplify a radical that's not a perfect square. And we have to look and see if it has perfect square factors that we can pull out. So, for example, like the square root of 20. Are there any perfect square numbers that go into 20 evenly? Are there any perfect square factors of 20? We'll start with 4. Does 4 go into 20 evenly?
Yeah.
How many times?
5.
Okay, so I can rewrite 20 as the square root of 4 times 5. Now the square root of 4 we know is 2, so I can take that out. When I take it out, it's a 2 on the outside, and we still have that square root of 5 underneath the radical. Okay, you might have learned the factor tree method in middle school, which I don't teach, but if you want to do it this way, that's perfectly fine. It's just longer, and I see many more mistakes when students do it this way, but it doesn't matter to me. Okay, but if you start with 4 times 5, and then you break up the 4, and that's 2 times 2. So what this says is 2 times 2 times 5 equals 20. So then you would put under the radical 2 times 2 times 5, and you would look for pairs. Why is that not working? There we go. A pair of 2s. When they come out, it becomes 1, 2, and that's still square root of 5. Look at all this additional work and writing I had to do, and this is even kind of an easy problem for this problem. I had to do a lot less here. So this is the way I'm going to teach you today. So let's go ahead and start on these slides. Let's go ahead and put all the numbers at the top, just the large numbers like square root of 54 and square root of 50 and square root of 48. I think there's one more. Square root of 72. I'm going to put all these other stuff down here. We'll start with the square root of 54. What two numbers multiply to give us 54?
9 and 6.
Okay, so we'll start with 9 and 6. Are either one of those numbers a perfect square?
9.
9's a perfect square. So those two numbers are great to break up 54 into. Because now, what's the square root of 9? 3. So we pull the 9 out. Oops. Let that go away. Okay. That 9 out becomes a 3 on the outside, and we still have that root 6 under the radical. So that's simplified as 3 root 6. That's it. Let's try the next one. Square root of 50. I know that 10 times 5 is 50. However, Are either of those factors, 10 and 5, are they perfect squares? That's not going to help us. Can we think of two numbers where we want to find the largest perfect square that goes into 50? Andrew?
25 and 2.
Oh, 25. 25 times 2 is 50. 25 is a perfect square. We can pull the square root of 25 out. That becomes a 5. So that's just 5 root 2. 48. 12 times 4 is 48. 4 is a perfect square. Are there any bigger perfect squares besides 4 that can go into 48? Um, 6 times 8 is 48. Are either of those numbers perfect squares? Why don't we start with, let's say we can't think of a larger number and we want to break up 48 into 12 times 4. Let's just say we start there because that does happen. Here's what will happen, okay? We break it up into 12 times 4 because we notice that 4 is a perfect square. We pull the 4 out, it becomes a 2. But look what happens. A lot of students would say, there's your answer, but that's actually not completely simplified because 12 has a perfect square factor still. What is it? 6 does go into 12 evenly, but it's not a perfect square. 4, because 4 times 3 is 12. So then we have to do this again, which is fine. So we break up the 12 into 4 times 3. We pull the 4 out. It becomes a 2 on the outside, square root of 3. So we have 4 root 3. So it would have been easier if we had broken up 48 into 16 times, whoops. Can I not move this while this is up? I can't. Shoot. All right. It would have been easier if I had broken 48 up into 16 times 3. It would have been less work because then I can pull the 16 out. It becomes a 4 and we have 4 root 3. But we got the answer the same way. It's just if there's less steps, you're more likely to get the answer and not make a mistake. The more steps you do, the more likely you are to make a mistake. Last one, square root of 72. 9 times 8 is 72. 9 is a perfect square, but there's actually a larger perfect square that goes into 72, and that's 36. 6 times 6. Now we pull the 36 out. The square root of 36 is 6, so that's 6 root 2. And we just simplified those radicals. And that's it. Peace out.